All right, 3.3, properties of logarithms. So this is chapter 7 in Algebra 2. So if you have your Algebra 2 stuff still, cool, check out chapter 7. So if you are taking log of a product, right? So this is talking about x times y. What you can do, as long as what's inside is being multiplied, then you can split it as log base log base b of x plus log base b of y. Now, if you were taking log base b of x multiplied by log base b of y, that's not the same thing. The multiplication has to be inside the log, right? X times y has to be inside. This is where people mess up. Now, if you're taking the quotient property, guess what? You subtract. Divide, you get smaller. Okay, that means subtract. And then if you have the power property, you just move the exponent to the front. So, express each logarithms in terms of log 2 and log 3. So, this first one, I have to think I have to think of the prime factorization of 96. Because I want to express it as 2 to some power times 3 to some power, right? Maybe an easier one I could have started with is like 8. I could rewrite 8 as 2 to the third power and then use rule of logs. So I'll start with 96. Maybe 3 times 32. Yeah, 3 times 32. Okay. And 32 is just, 4 times 8. This is 2 and 2, 4 and 2, and then this is 2 and 2. So I can literally write log 96 as log of, 3 times 2 to the 5th power. Right, because 3 times 2 times 2 times 2 times 2 times 2 is 96 to the 5th time. It's kind of like a wedding. Right now, you should speak if you are like, what the heck is just going on? Don't hold your peace at all. Cool. So now I have a product, right? Log of a product. I can divide it, I can split it and write it as log of 3 plus log of 2 to the 5th. But wait, there's another property we could apply. Not just the product property, but what now?
You could take log, factor log.
Power. We can't factor log. It's kind of like, it's not a number per se, it's an operation, right? It's an operation. You can't just have log. It's got to be log of something. There always has to be something with it. But someone said power, so I have this 5, and I can bring it to the front thanks to the power property. So this is just going to be log of 3. Log of 3 plus 5 log 2. And that's it. How are we feeling about this so far? Okay, I'll give you maybe like 10 seconds. Try B. Okay, you kind of see we want to break down the numbers into, 2 to some power, 3 to some power being multiplied. We have a quotient rule. Give it a shot yourself first. Okay, so we want it in terms of 2 and 3. So first thing I'm going to do is write 32 in terms of 2 and write 9 in terms of 3. So this is the same thing as saying, oh, it's so big, log of 2 to the 5th over 3 squared, right? Log of 2 to the 5th, 3 squared. Having parentheses might help us a little bit, yes?
log 2 minus log 9 and then do like log 2 to the 5th.
Yes, it does the same thing. I'm just writing it in terms of 2 and 3 first. So I have quotient. So that means the top log of 2 to the 5th minus the bottom log of 3 squared. And now I can use the power property. Bring out the exponents in front. So I have 5 log 2 minus 2 log 3. Okay, are we ready to go on? Yes? Okay, cool. So now we want to evaluate each logarithm. That's the next part. Evaluate each logarithm. So we have a base of 2. Before we had common log, which is base 10, and we just wanted to write them in terms of 2 and 3, log 2 and 3. Maybe I should have specified, here we just have log, and log literally means base 10, right? It's the same thing as saying base 10. So evaluate each logarithm. Okay, so we have base 2. If I could rewrite the inside as 2 to some power, that would be great. So let's think. Root 32 is the same thing as saying 32 to the 1/2 power, exactly. And up above, we know 32 is the same thing as 2 to the 5th. So I have 2 to the 5th to the 1/2 power. So what's my actual exponent here? 2 to the 5 over 2. So I'm going to rewrite this as log base 2 of 2 to the 5/2. So root 32 is the same thing as 32 to the 1/2 power. 32 is just 2 to the 5th power. So when I have an exponent to an exponent, you just multiply them. 5 times 1/2 is just 5 over 2. Okay, let's use the power property. So bring that out front. This is going to be equivalent to 5 over 2 times log base 2 of 2. What does log base 2 of 2 equal? This is just equal to 1. So that goes away, and we're left with 5 over 2. No calculator required. Bomb.com, there's going to be at least one question like example 2 on your test. Yeah. One of these couple will be similar too. All right, try out B. Try out B if you haven't already. Give it a shot. Try out B.
Why is the answer?
That's the exponent we brought out front, so it's 5 over 2 times 1, because log base 2 of 2 is just 1. Do you have questions over this one? Hopefully you are trying them by yourself. I'm going to explain it. I'll explain it out so we all are on the same page. So the first thing I see at base 7 says usually I'd like to write the inside as a 7 as my base, right? 7 to some power, that'd be great. So I start with the 6 over 49, the same thing as 49 to the 1/6 power. And then I know 49 is just 7 squared, so if I have 7 squared to the 1/6, you multiply those two and 1/6 because that's the exponent rule. per hour, whatever, right? You have an exponential next thing multiplied. 2 times 1/6 is 2/6, which is just a third. So this is the same thing as 7 to the 1/3. We bring the 1/3 out in front. Thank you, power product of logarithms. And then I have 3 times a third. Okay, well 3 times 1/3 is just 1. Log base 7 of 7 is just 1. 1 times 1 is just 1. Questions? Okay, are we feeling okay about this? Maybe. Okay, let's try next one. Try out C. Oop, where'd it go? Okay.
I did it a different way, but that's the answer. Is that fine?
What?
I did it a different way.
How did you do it?
I factored it into ln to the e over 12 over e to the 4.
Oh, I see. So you wrote e to the 12. Okay, so you wrote ln of e to the 12 over e to the 4. And then you say, okay, this is the same thing as ln of e to the 3rd. No, wait, subtract, sorry, 8. And then you're like, okay, exponent, you bring the exponent out, so 8 times ln e, and ln e is 1. You get the same thing, yeah. That's good. All right. How do you feel about this so far? Yeah, okay. This isn't too bad of a lesson. It's not too bad. It's more approachable than 3.4, so cool. I just want to make sure we are prepared, have the, growth mindset, positive mindset for next time. Expand each logarithm. So right now everything's condensed into one, so I want to expand it as far out as possible. Right, so I see log base 2 of all the things being multiplied, so I could write this out as log base 2 of 4 plus log base 2 of m squared plus log base 2 of n to the 5th. I'm trying to expand. When it says expand, it means make bigger. When I say condense, take a long thing, make it smaller. Yes, Andy? No.
No.
Because I could have like quotient where have something that's being divided and I expand it out into division. Yeah. Let's see. I want to do, I need to bring the exponents out front. Come on. Bring the exponent out front, bring the exponent up front. And then, this log base 2 of 4. Could I rewrite 4 in a different way? Yeah, 2 squared, okay. So this is going to be log base 2 of 2 squared plus 2 log base 2 of m plus 5 log base 2 of n. Deal with this pesky one right here. Bring the 2 out front. 2 times log base 2 of 2. That's just 1. So our answer is going to be 2 plus 2 log base 2 of m plus 5 log base 2 of n. So 100%, there's going to be a problem on your test. It's just like one of this example. Yay. We must expand this out. Make it large, make it big. Okay. So I'm going to show like every step. You could make it shorter if you want. That's also fine. So I see division, so I'm going to write this first as log of 2xy squared minus log of 5 root z. Now you could have skipped that step, but the issue is don't mess up your signs. You might forget to distribute a negative. That'd be unfortunate. Be very unfortunate. Okay, so this first one, that's nice. They're all just being multiplied, so I can just write it out as log of 2 plus log of x plus log of y squared minus log of 5 plus log of z squared, square root of z, square root of z. This is what I mean when I say you might forget to distribute your negative, because this should be a negative in front. Because we're, technically it was on the bottom of my quotient, so it should be subtraction. Let's see, what else can we fix? Bring the power rule up. Well, technically this is, square root of z is just z to the 1/2 power, so I'll bring the 1/2 to the front. So I'll have log of 2 plus log of x plus 2 log y minus log 5 minus 1/2 log of z.
If you don't write out with z like that, is that wrong?
What do you mean?
Like if you don't take out the 1/2.
Yeah, because you have to fully expand it out. So the 1/2 is the exponent. You have to have all exponents in the front. No quotients or products. You can't take log of any quotients or products in your answer. You guys want to try out the next one? Just kidding. Try it out. You don't have an option. Okay, good talk. Give it a shot. Keep in mind this top is 2x minus 3. Hopefully a little bit in red helps you see where I got some of these answers. And then there's a couple things we have to do. Bring the exponents in front. Distribute the negative out. Notice there's 5 elements. Oh my gosh, 5. So long. Yes?
Since they're parentheses, is that why you don't distribute it?
Because there's what?
Like 2x minus 3.
Because it's not being multiplied inside, they're being added and subtracted, so I can't split it. Yep, I needed to give you guys an example of that because it's tricky. Only if you're multiplying inside or a division, right, inside what you're taking log of, that's when you can split it. Okay, that was expanding. What do you think the next part is?
Compressing.
Condensing, compressing, making it smaller, literally, right? Compressing, condensing, perfect. So I have something big, I want to make it smaller. So our goal is to end up with 1 log term. That's our goal when we are condensing. Take something big, make it into 1 term. So first, let's deal with these things in the front. How do I deal with these coefficients? Yeah, we put them as our exponent. Excellent. So this is going to be log base 4 of x to the 1/2 minus log base 4 of x minus square to the 3rd. So we have our exponents back, and then as long as we have the same log base, I have log base 4 and log base 4, they're being subtracted. So what does that mean I should do to inside? Divide. Okay, so this is going to be log base 4 of, let's see, x to the 1/2 over x minus 2 to the 3rd power. So in my final answer, it's going to be log base 4 of square root of x over x minus 2 cubed.
Why did it show work? You don't need to simplify it.
There's no way to simplify it. Because if you will expand it out, this is the simplest thing. This is fine.
Why did it show work?
Yes, you must show work. That is my answer always and forever. You must show work. Because what if you accidentally do it in your head and you forget a negative? Remember the one with the 5 terms? Cool. You get very little points. But if you show work, I see what you're doing, what I'm testing you on, and give you as much partial credit as possible. So it's your decision if you want to show work or not. But I'm a very nice grader. If you've ever been on the Gods of Partial Credit Please Descend end, you see I'm a nice grader. But you also can talk to some people who never show work, and I literally write it on their homework every time, and that's why they have 50% on their homework grade, because they literally don't show work. It is what it is. You do you. Okay. Let's try the next one. Give it a shot. Try out B. Give it a shot yourself. Try out B. Are you done? Try out B. Okay. Yeah, it's actually a pretty short one. That's it. I just changed the order because I like having my things with parentheses on the right side. That's it. Very short. Parentheses are your best friend when you're doing math because then it helps prevent you making mistakes. Because maybe you would think this is ln of x to the 6 and then being multiplied, right, by... It helps you know that everything is inside. You're taking log of that whole thing. Yeah. Okay. So, we still have 1 page left, right? Perfect. Wow. Okay. That's good. That's good. We might start a little bit of 3.4 because I worry it will take a while. But no worries. Change of base formula. Okay. Slightly not needed, considering your calculator does it for you. Now, before we switch over to the TI Inspires, we had the 84s. So maybe the seniors last year had the 84s. Maybe. Their calculator, you weren't allowed to do any base. You either had E, natural log, or you had to have common log. Your calculator says, you know what, whatever, I could take any base. Now, I'll show you what I mean. Do I have it open? Nope. Great. Good to know. Oh my gosh, come on. Hate the surface. Sometimes. The screen's vibrating. I need a new computer, so it's really hard to see right now. Yeah. Okay. So, more or less, you have log base b of x. You can rewrite it in terms of a common log, where you have the old base, log of your old base on bottom, and then log of whatever's on the inside originally is on the inside on the top. That was change of base. This is if you wanted a base that was anything other than E or 10. Come on. So I could do any base I wanted. I just have to push Control and then 10 to the x. Do you see how there's a slot right here where my cursor is? This allows you to put anything as the base. To my knowledge, this was the first calculator that allowed you to do this. Because it takes a lot of computing power. Because literally your calculator is doing the change of base for you. Kind of cool. It is what it is. I mean, if I was a 16, 17-year-old, I wouldn't care about this. But as your teacher, I'm like, wow, this is powerful because that means I don't have to do change of base formula on the test for you. But it's good to go through anyway. So cool thing is I could even put like pi as my base. Come on. Oh my god. Yep. Wonderful. Wonderful. This is... So we could put anything as our base. It doesn't just have to be E or the common log. So normally, I mean, so in past years, the teacher like highlights this and they say memorize, right? And like calc okay. I don't even know if I'll even give it to you, but it's good for you to like realize what your calculator is doing. So I have log base 6 of 4. So this is the same thing as, so let's do in terms of the common log. So log of the original inside over log of the old base over log 6. So log 4 over log 6. Do you guys want to try this in your calculator? Sorry, ask it like you have a choice. Get out your calculator and try it. Come on. Okay, so I have log of 4 divided by log of 6. Because automatically will put the 10 in for you if you don't write it, because it assumes 10. Alright, cool, that's the answer. That's how we used to have to do change of base. And you'd have to remember it's the old base on bottom, not on top. Oh my god. But now you can just plug it straight into your calculator and we'll get the same thing. Log base 6 of 4. Oh my god, I wonder what it's equal to. Oh, same thing. Amazing. Amazing. Okay, let's go back. Okay, so this is just 0.774. And try the next one. So this is just log of the top, or I'm just using base 10 over log of the old base. This is how we used to have to do it. Now you can just plug this straight into your calculator. Wonderful. So I'd like to go through a page of the 3.4, and then I can let you work on Alex and homework. I just, worry about you, so gotta make sure you understand it. I know it looks like there's a lot of problems. It's not too bad, and also you'll have like a solid 20 minutes to do in class. Some of them are very short.
Is there one?
What?
This is there one?
No. Turn the page.
Oh.
It says like the bottom. It says
I
somewhere.
think it was page.
No. So we're on the top of page 20. Top of page 20. Let's go through this one page, and then we'll have like 2 pages after this. That's much more manageable. Okay. Exponential and log functions. What? What? Yeah? No? Maybe? Okay. So, hopefully this first page is a little easier. An exponential equation is an equation containing a variable in an exponent. Okay, we already knew this, right? So for instance, if I was just plotting this, okay, it would literally be the graph of 3 to the x but left by 3, and it's about, multiply all our y values originally by 2. So it's stretched vertically, and it's left by 3. That's it. That's the transformation. But what if I want to know, where is this equal to 7? Like, what the heck? So we'd have to solve for the x value that would make this true. So we're dealing with the equations, not functions, right? Functions, you plug in x's, you find y's, blah, blah, blah. But an equation, we set things equal, and we try to solve for x. And on the right side, okay, if our bases are the same, guess what we can do to the exponents? Set them equal to each other, and then you can solve for x. So ideally, you want to make the bases identical, right? So you want to make the bases identical. So if I have 3 to the x is equal to 3 to the 5th, then you see, oh, since the bases are equal, the exponents must be equal, and we see, okay, x has to equal 5. If log of x equals 3, I can literally raise each side to the power of 10. And then if you have 10 to the log base 10 of x, you just get x equals 10 to the 3. Okay, that was a lot of nonsense. Let's see what this actually is. Because I distinctly remember teaching this in my Algebra 2-ish course. So I know you've done this before, just trying to get your gears going before we hit the harder stuff. So ideally, we write everything within the same base. Can I rewrite 16 in 4 to some power? Yeah, okay. So on the left, I have 4 to the x plus 2. On the right, I have 4 squared to the x minus 3. I just write 16 as 4 squared, and then I must multiply my exponents on the right side. This is the hard part, remembering rules of exponents from Algebra 1. 4 to the 2x minus 6. And then since the bases are equal, I can now set the exponents equal. Solve for x. I have a equals x. Okay, so this is okay. So far. All right, so we're trying to gradually walk you into the Santa Monica beach, right? Like nicely into the ocean, not a giant cliff in Oregon pushing you off. Nope, we're trying to gradually lead you there. So hopefully this wasn't too bad. Build your confidence, that'd be great. Huh? Oh no, we can solve it. It's just, we gotta gradually walk you into the ocean, okay? Let's try B. How can I rewrite them in terms of the same exponent? So on the left, I have 1/3 to the n. On the right, I have, let's see, 1/3 times a third is a ninth, times a third is 1 over 27, times a third is 1 over 81. So 1/3 to the 4th power, and then to the 2/3 power. Oh my gosh, crazy. So since I have the same base, all I have to do is set the exponents equal. N is going to be 4 times 2/3, which is just going to be 8 over 3. All right. What do you feel so far? Just, what do you feel? Yeah. Okay. Little poll. I know this is like kindergarten-y, but how do you feel so far? I see like 2 people appreciate it. Okay, cool. All right. Let's try the next one. So I have 4 to the x equals 13. Now, as Shane kind of alluded, you can't write 13 in terms of 4. Yikes, yikes, yikes. And I'm trying to solve for x. If only I could take log base 4 of both sides. So if you have an exponential on one side, you can use log to get rid of the exponent. More or less, it's a change of base. So if I take log base 4 of both sides, log base 4 of 4x equals log base 4 of 13. I can move the x to the front. So now I have x times log base 4 of 4 equals log base 4 of 13. The log base 4 of 4, well, that's just equal to 1. So I have x is equal to log base 4 of 13. Normally they make you do change of base. You have a TI Inspire calculator, so guess what? You can just plug that puppy in. There you go.
because you did X?
What?
Like, how did you know this was log of 4?
Because that's the base. I have 4 to the x on the left side. That's my base is 4. So I take log base 4 on both sides. Yes.
I think instantly just putting log with the 13 since we know how to.
So we did that. We did the work and we did that. I don't know a clearer way of saying you must show work besides saying, Andrew, you must show work.
I know.
Andrew, you must show work. Every time you talk to me, I'm just going to say, you must show work. You must show work. Okay. I don't want to take off points because you forget things, because people forget things all the time. Okay. So let me just clarify, right? So you have an exponential on one side, right? You've got to use log to solve for exponent. So normally this is a change of base. But lucky you, you have it in Spire and you can just plug it straight in. One less thing for you to have to know. Okay. Next one. I have an exponential on one side. I can't write 8 as e to some power. That is an integer power, right? It's going to be like, I don't know, it's e to the 2.56 or something, right? It's going to have to be a decimal. That's an issue. So what I would like to do, okay, I have to, my x values in the exponent. I want to like have my x down. It'd be great. What can I do to like get rid of e? I can take of both sides. Take ln of both sides. ln of e to the 2x plus 1 equals ln of 8. Power property. This is exactly why the third section was rules of logs. Because now I have 2x plus 1 times ln of e equals ln of 8. ln of e is just equal to 1. So I have 2x plus 1 equals 8 ln of 8. 2x equals ln of 8 minus 1, and then divide by 2. ln of 8 minus 1 all over 2. Plug that into your calculator, you'll get about 0.54. So we kind of started covering, got to have both sides in terms of the same base. If you only have an exponential on one side, you can take log of both sides. Just what's the base of your exponential? So in part C, the base of our exponential was 4. So we took log base 4 of both sides. In D, our base was E. So we took log base E of both sides. That's literally what ln is. ln is log base E. Cool. All right, so that's a good stopping point for today. I think we definitely set ourselves up for success and have more time with marinating. You have a solid 23 minutes to work on homework or Alex.